What if the search for alien life is pointless because we're the aliens? We point telescopes at distant stars and scan the dark, waiting for a signal, a microbe, anything alive. We keep asking whether life exists out there, but far fewer people ask a stranger question. What if life came from out there? What if Earth didn't invent life entirely on its own, but inherited some of its most important ingredients from space? Look at a comet streaking past the sun. It looks like ice and dust, but inside that frozen debris are organic molecules, carbon-based compounds that life depends on. Think of them as the chemical alphabet. On their own, they're not alive, just letters, but without letters, you can't write a sentence. We know these molecules exist beyond Earth because we found them. Carbon-rich meteorites contain amino acids, the building blocks of proteins. Asteroid samples returned to Earth carry sugars, nucleobases, and complex organic chemistry. Space, it turns out, is not empty. It's busy, reactive, and chemically creative. Now rewind to the early Earth. The planet was hot, unstable, and constantly bombarded by asteroids and comets. Rocks from space slammed into oceans and continents that were still forming. Some scientists propose that along with water and minerals, those impacts delivered organic ingredients that helped kickstart life's chemistry here. That idea is called panspermia. Panspermia doesn't mean aliens designed us. It doesn't say intelligent beings showed up and built DNA. At its most grounded, it says something simpler. The raw materials for life may not be uniquely Earth-made. Earth may have mixed its own chemistry with supplies delivered from space. Picture a shallow tidal pool on the young planet. Amino acids drift, bond, and break apart. Energy from sunlight, heat, and lightning drives reactions forward. Even if the ingredients arrived from elsewhere, the assembly still happened here. Earth wrote the story. Space may have mailed some of the letters. This idea is intriguing, but it's not proven. A skeptical scientist would point out a major problem. If life's ingredients came from space, or even life itself, then where did they originate? Panspermia can move the mystery without solving it. Instead of asking how life began on Earth, you ask how it began somewhere else. There are also practical challenges. Space is harsh. Radiation, vacuum, and time are unforgiving. While some microbes on Earth can survive extreme conditions, we don't yet have direct evidence that living organisms traveled through space and started life here. The strongest evidence supports a modest version of panspermia. Molecules arrived, not organisms. Still, even if panspermia turns out to be wrong, one fact remains unavoidable. Every atom in your body has a cosmic history. The carbon in your cells was forged in ancient stars. The oxygen you breathe was cooked in stellar cores and scattered by explosions long before the sun existed. Earth didn't make these elements from nothing. It inherited them. Seen from deep space, Earth is a small collection of recycled star matter that learned, somehow, to think. Whether life's chemistry began entirely here or was nudged along by material from beyond, we are not as separate from the universe as we like to imagine. So maybe the question isn't whether aliens exist. Maybe it's whether the line between us and out there ever really existed at all. We may never meet aliens. We might just be them.